Okay, so square root symbols are also called radicals. What do we need to know? Well, we know that the square root of 16 equals 4. And the reason being is because 4 times 4, which is 4 squared, and the square root and squared are inverses, therefore they cancel each other, so it's just 4. So we know that anytime we have something twice or squared, we can cancel it and take it out. Well, 80 is not a perfect square. And if you don't know that, you can literally come here and do the square root of 80. And if it gives you an ugly decimal, that means it's not a perfect square. Okay, so this is not a perfect square. So we're going to do the factor tree. Now, my word of advice is to always start with 2. If 2 doesn't go into it, try 3. You want to start with the smaller numbers, because then it'll keep it organized for you. So does 2 go into 80? 40 times. Does 2 go into 40? 20 times. Does 2 go into 20? 10 times. Does 2 go into 10? 5 times. Now, do you see how all of these numbers are prime? That means I'm done. That's as factored as we can get 80. So anything that has a pair, 2 has a pair, 2 has another pair. Does this 5 have a pair? No, so this is our leftover. Where do you put leftovers? Like if you go to a restaurant, where do you put your leftovers? In the fridge, right? Yes? No, you don't put your leftovers in the fridge? Right away?
No, yeah, because I'll be going home and I'm like, okay, I agree.
Oh my gosh. Okay, normal people, not y'all, put their leftovers in the fridge, okay, inside. Okay, so what I want you to know is that, y'all, this is the same as 2 squared and 2 squared, right? You don't have to write it like that every time, but I want you to realize the square root cancels the squared. That's why we only take out a single 2 here. Here I'm going to cancel the squared and take out a single 2. And my leftover goes inside. What's my leftover? 5. What is 2 times 2? So my simplified answer is 4 square root of 5. Now we can check our work. You can literally type 4 square root 5 and it should equal the same ugly decimal. Does it? Yeah, so we did it right. Now, the inside of your house will not always be prime. Like if it was 10, well, what goes into 10, y'all? 2 and 5. Is that a pair? No, so you can't simplify the square root of 10. So there are other numbers that will go inside your house. It's not always a prime number. Okay, let's look at the next one. So again, 288. Is it a perfect square? If we don't know, we can check. It's not. Okay? So I want you to realize, does 2 go into 288? How many times? 144. Y'all, is 144 a perfect square? Yeah, what times what is 144? And yes, I do realize these are not prime, but do they match? Therefore, I can stop. Now, if you didn't realize that 144 is a perfect square and you kept going, that's fine. You would have taken out multiple numbers that would have multiplied to 12, and you'd still get the same thing. You'd probably have 2 times 2 times 3, and then whatever's left over. So as long as your other number is prime, your leftover is prime, or leftovers are prime. So again, what matches comes outside of the house, and your leftover stays inside. And again, we can check our work. Do they match? Yes. Okay, let's look at number 3. What do we know about radicals? If either they match, or you just keep going like we did in the first one. Yeah, but like 40 is not a perfect square, so we kept going. Now, if you didn't realize 144 was a perfect square, that's fine. You could have done 2 and whatever, and then 2 and whatever, and you would have kept going forever.
So when it's a perfect square, you change the number?
You can stop. Yes.
I thought you continued to all the way down.
You don't have to if you end up with a perfect square. So here, I want you to know that the rules of radicals, when it's a fraction, you can separate the numerator and the denominator. Are one of those perfect squares?
25.
Yeah, so what's the square root of 25? 5. What about the top? Is it a perfect square? No. So we're going to do our factor tree. Does 2 go into 8? How many times? And then 4 is a perfect square with 2 and 2. So I have a pair of 2's, and I have a 2 left over. So the pair comes out, and the leftover goes in. Now, does 2 over 5 simplify? No, so this is your answer. Now, if you remember in these calculators, you can do alpha y equals enter, and it'll give you a fraction. So I could do 8 over 25. And then I could do alpha y equals enter, 2 square root 2 over 5. Are they equal? Yes, so I did it correctly. Okay, now let's look at number 4. What's different about number 4? Well, it has a negative out front, but it also has a number out front. Okay, we're not going to worry about that guy until we know what 32 breaks down to. So let's figure it out. Does 2 go into 32?
Yeah.
How many times?
16 times.
Is 16 a perfect square?
Yeah.
Yeah, what times what gives you 16? 4 and 4. So since it matches, we can stop. Now, that negative 5 is still there. And I want you to realize, see how that negative 5 is touching the house, the radical? That means we're multiplying. So I'm going to bring that multiplication symbol. And what am I taking out of the house? A 4. And what was my leftover that stays in the house? 2. What's negative 5 times 4? Now, I want you to realize that's because they were touching. Now, what if, goodness gracious, what if it looked like this? Well, I want you to realize that negative 5 would come down, that plus sign would come down, and square root of 32 was 4 square root of 2. Are these like terms? They're actually not. Okay, square roots are like variables. To combine the coefficients, they have to have the same square root. So this does not have a square root, and this one does. I'm pointing at it, I swear. Give it a second. There we go. That one doesn't, and that one does. Therefore, they are not like terms. So that is our answer. I boxed it. There we go. Okay. So I just want to talk about that. Now, number 5 is different. What do you notice on this one? You have a negative on the inside of the house. Watch what happens if you're so smart. Okay, if I type it in my calculator, it tells me non-real answer. And he's exactly right. It's because it's an imaginary number. So I'm going to explain why we have imaginary numbers, because I want you to understand where they come from. We didn't just pull this out of thin air. Okay? I know sometimes it sounds like it. So remember, if you took algebraic reasoning or algebra 2, we talked about inverses. What are inverses? What is an inverse? It's your opposite operation. So the inverse of plus is minus. Okay? So you were right. Okay, so what's the inverse of something squared? The inverse is something that's not squared. It's the square root. But if you graph the square root, y'all, it's only half of an x squared. And that's because you can't take the square root of a negative. So everything that should have been over here is imaginary. I don't know if I spelled it right, but this is what we got. I did not spell it right. Now it's good. We're good. It doesn't mean I spell right. I teach math. Spell check's my best friend. Be kind. I went to college. Oh, okay. Oh my gosh, I'm done talking to you. Okay, now I have this. So what this means, y'all, is I equals the square root of negative 1. So anytime you have a negative on the inside, what you're going to do is you're going to put an I in front and make it positive. Well, what's the square root of 81? 9. So the answer is literally 9i. So it's just saying imaginary 9. 9 is imaginary. Okay, so let's look at number 6. Now, the reason we're doing this is because do y'all remember the not the quadratic formula? Yes, the quadratic formula. Oh my gosh. Yeah, quadratic formula. Do y'all remember this guy?
No.
Okay, so obviously we're not learning it today, but we need to understand how to simplify it, and since we're simplifying radicals today, that's what we're talking about. Okay, so what I want you to know is we're going to simplify the radical first. So first off, it's a negative, so I'm going to put an I right in front of the house, and I'm going to make it positive, and we're going to break down 28. Does 2 go into 28? How many times? Does 2 go into 14? 7 times. Well, 7's prime, so I'm done. So I have a pair, and I have a leftover. So when I rewrite this, I have 10 plus or minus. Now the way you write it when it has a pair is going to be 2i square root of 7. The I should be between the number and the radical. It should always be right in front of the radical. Okay, over 5. Now, doesn't 10 over 5 simplify? Yeah, so technically, I can separate the denominator and have 5 and 5. What's 10 over 5 simplify to? No. 2. Now, does 2 over 5 simplify? No. So, I want you to realize because it has a plus and a minus, this is technically 2 answers. So, we have 2 minus 2i square root of 7 over 5. 2 plus 2i square root of 7 over 5. Y'all, the side conversations need to stop. That's enough. Because it had a plus and a minus, meaning there's 2 answers. You did. Okay, so look at number 7. Now number 7's different because what's the square root of 25? 5. So we can simplify it. So we have 9 plus or minus 5 over 4. And now we have to separate it. So 9 plus 5 over 4, 9 minus 5 over 4. What's 9 plus 5? What's 14 over 4 simplify to? 2 goes into both of them, right? So what's half of 14? And what's half of 4? 2. What's 9 minus 5? 4. Does 4 over 4 simplify? To what? 1. So we have 1 comma 7 over 2. And now we actually aren't going to do number 8 and 9 today. Do not cross them out because we're going to do them later.